Welcome to the Deep Dive, the show where we unpack complex topics to give you that shortcut to being truly well-informed. Today we're embarking on a really crucial deep dive, especially if you're navigating the modern business world, computer networks, and the internet. Now, if you're a student, maybe at the Dr. Sampak College of Business or, a working professional interested in management, business operations, or MIS, this deep dive is absolutely crafted with you in mind. Our mission today is pretty straightforward. Help you grasp the essential concepts, the frameworks, and the real-world uses of computer networks. We want you ready to confidently manage the future. And just so you know, all the insights we're sharing today, they're rooted right in the material from Richard Tedmon and Casey Wilhelm's Connect Master, Management Information Systems, published by McGraw Hill in 2024. Before we really jump in, please remember to like, subscribe, and follow the deep dive. It helps you stay updated. And definitely share this with classmates or colleagues. Oh, and leave us a comment. We genuinely love hearing your thoughts and questions. Okay, let's start right at the beginning.
What exactly is a computer network? And why is it so completely fundamental to, pretty much all modern business? Think about maybe a small business just starting out, trying to share maybe one expensive printer or just one internet connection for a few computers. That basic setup, just connecting devices to share stuff, that's essentially a network, isn't it?
That's a perfect way to think about it, yeah. At its heart, a computer network is really just two or more connected computers or devices that can share information and resources. What's really fascinating, though, is how these simple connections scale up. They power everything from that tiny office right up to huge global enterprises. We can start small. The most personal scale is a PAN, a personal area network. Think about your Bluetooth headphones connecting to your phone, or maybe your smartwatch talking to your tablet. It's just connecting devices right around you in your personal space. Then moving up a bit, we get the LAN, the local area network. This physically connects devices within a single kind of confined area. An office, a school building, maybe even just your home, your printer example. Spot on for a LAN, sharing resources within one building. But businesses grow, right? They open offices in different cities. And that's where the WAN, or wide area network, comes in. WANs connect devices remotely across different geographic locations. So imagine a company based in Dallas, but with branches in Houston and Austin. A WAN connects those offices, making them operate like they're all part of one single, seamless network. And here's a really important distinction, something our source material highlights. We often talk about internets, lowercase I, and the internet, uppercase I.
Okay, what's the difference there?
Well, an internet lowercase is really just any collection of interconnected networks. So that company connecting its LANs with WANs, it created its own private internet. But the internet, the one with the capital, that's the big one, the global network of networks. It's not some, magical cloud system. It's just the largest internet connecting billions of devices and people all over the world.
Right. So given that massive scale, how does this colossal global network actually work? How does the internet manage to get our data from, say, here to Australia in seconds?
Yeah, that's the million-dollar question, isn't it? It's not just one giant wire, that's for sure. If we connect this to the bigger picture, the internet relies on this incredibly vast, intricate system, hardware and specialized software. Think of it maybe like a giant highway system for data. The superhighways, those are the massive fiber optic bundles called the internet backbone.
Okay, the physical cable.
Exactly. And this hardware is managed by a set of rules, instructions called the Suite of Internet Protocols. Now, when you send an email or watch a video, your data doesn't go in one big chunk. It gets broken down into small, manageable pieces called packets. These packets are stored briefly on servers, basically powerful computers designed to hold and dish out information.
Right.
And here's the clever part. Specialized hardware called routers direct each packet. And these routers are incredibly smart. They're constantly calculating the fastest possible route for each packet at that exact moment. So packets might even take different paths before they get reassembled perfectly at the destination. It ensures efficiency.
Wow. Okay, so for all those packets to find their way across this huge web, every single device must need some kind of unique address, right? This is where IP addresses come in. We hear that term all the time.
Precisely. Every single device connected, your laptop, your phone, a company's web server needs a unique identifier, and that's its IP Internet Protocol address. It's basically a numerical label. It identifies the device and lets it talk to others. And for businesses, understanding the difference between static and dynamic IPs is pretty important.
Okay.
Static IP addresses are permanent. They don't change. Businesses often use these for things like their web servers or email servers. Why? Because customers need a consistent, unchanging address to find those services. On the other hand, dynamic IP addresses are temporary. They get assigned when you connect and can change each time. That's what most home internet users have. And the glue holding this all together, the fundamental rulebook, is TCP/IP. That stands for Transmission Control Protocol Internet Protocol.
Ah, okay. TCP and IP, 2 parts.
Yep.
Think of them working together. TCP is the part that makes sure your data packets get assembled correctly before sending, and crucially, reassembled perfectly when they arrive. So your email actually makes sense. It's not just jumbled data. And IP, like we just said, is all about addressing those packets and routing them to the right destination across the network, which, naturally leads to the next question. How do businesses actually use all this global connectivity for communication, for services, beyond just sending basic data back and forth?
Right, because the internet isn't just a technical backbone. It's completely changed how we communicate, how we access services. As, future business leaders listening to this, you'll be using its core applications constantly. What are some of the most critical ones we should know? Oh, absolutely. The internet provides a huge range of essential resources. The most visible one, of course, is the World Wide Web, WWW. That's the part specifically designed for displaying, formatting, and retrieving data using web browsers, like what we're doing right now.
Yeah.
But it's really important to remember the web is just one application, albeit a very powerful one, that runs on the internet.
Okay, so the web isn't the entire internet.
Exactly. Other vital services include things like instant messaging and chat apps crucial for real-time collaboration. There's FTP, File Transfer Protocol for moving large files around, good old email, still a cornerstone for business comms, and EFT, Electronic Funds Transfer, which handles digitized bank transactions, powering things like e-commerce and online payroll. Now, the web itself has evolved quite a bit. Its standards are developed by the World Wide Web Consortium, the W3C, and the key bits we interact with daily. HTTP, Hypertext Transfer Protocol, that's how your browser talks to servers. The URL, Uniform Resource Locator, that's just the web address. HTML, Hypertext Markup Language, the standard language for creating web pages. And hyperlinks, those clickable things that connect everything together. And we've seen the web change dramatically. Web 2.0 was a massive shift. It became about interactivity, user-generated content, collaboration.
Like social media and blogs.
Exactly. Social media, blogs, wikis, places where you weren't just reading content, you were creating it, participating. This era also saw the rise of SaaS, software as a service, which we'll touch on more later. And looking ahead, we have Web 3.0. This next evolution is about using vast amounts of data more intelligently. It integrates deeply with smartphone apps, leverages the Internet of Things, IoT, supports ubiquitous computing technology embedded everywhere. Think advanced 3D graphics and, crucially, a much deeper integration of artificial intelligence, AI, into business, driving automation, smarter insights.
Okay, so beyond the general web that most of us use daily, there are these specialized systems harnessing network power in really fascinating ways. You mentioned IoT, but also things like geographic information systems.
Indeed. Take Geographic Information Systems, or GIS. These systems are all about capturing, analyzing, and managing spatial location data. Think sophisticated maps and 3D scenes. For businesses, this is incredibly valuable. Retailers use GIS to analyze regional demand, figure out the best spots for new stores, or tailor products.
Location, 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 but with data.
Precisely. Logistics companies optimize routes. Real estate developers analyze land data. It's about turning location data into a real competitive edge. Then there's cell phone communication. We all have one, but think about its business impact. At its core, it's a two-way radio, yes, but its omnipresence is key. Mobile connectivity enables mobile commerce, real-time supply chain updates, remote workforce management, instant customer support. It's a powerful mobile data hub connecting everyone to the internet, everywhere. And then the Internet of Things, IoT. It's not just hype. It's about everyday objects, smart thermostats, factory sensors, wearable tech connected to the internet. They gather data, analyze it, sometimes talk to each other, turning raw data into useful information or automated actions. What's really accelerating IoT now is 5G connectivity, the next generation of mobile.
Faster speeds, right.
Much faster speeds, yes, but also greater capacity and, critically, much lower latency.
Latency. That's the delay.
Exactly, the lag time between making a request and the task actually happening. Super low latency is essential for IoT. It enables truly connected smart cities with real-time traffic adjustments, sophisticated factory automation, even more responsive smart home tech. For businesses, 5G fuels things like predictive maintenance on machinery, autonomous delivery vehicles, and incredibly personalized customer experiences in real time.
Okay, building on that idea of everything being connected, let's shift to maybe one of the biggest game changers for businesses using these networks, cloud computing. I mean, if you're listening and use Google Docs or you stream movies, you are absolutely using the cloud. It has fundamentally changed how businesses operate, big and small.
Oh, fundamentally is the right word. Cloud computing is basically a model where things like processing power, data storage, software, applications, and other services are delivered over a network, usually the internet. The key is it removes the need to store data or run software directly on your device or your company's own physical servers. The U.S. National Institute of Standards and Technology, NIST, outlines 5 essential characteristics that really define the cloud and make it powerful for business.
Yeah, what are those?
First, on-demand self-service. Businesses can get computing resources like servers or storage automatically when they need them without needing to talk to a human provider. Just click a few buttons. Second, broad network access. Services are available over the network using standard devices, laptops, phones, tablets. Third, resource pooling. The provider's resources serve many customers, assigned and reassigned dynamically based on demand. Think of it like sharing a big pool of computing power. Fourth, rapid elasticity. This is huge. Capabilities can be scaled up or down really quickly, even automatically, to match demand. Perfect for handling busy seasons or sudden growth spurts. And fifth, measured service. Cloud systems monitor and control resource use, often letting businesses pay only for what they actually consume. Makes IT costs much more like a utility bill. Very efficient.
Okay, those characteristics really paint a picture. So translating that, what are the direct implications for businesses? Why is cloud computing just so critical now?
Its importance really can't be overstated. Businesses, large and small, can drastically cut their reliance on expensive internal IT infrastructure. Less hardware to buy and maintain. The advantages are pretty compelling. You get incredible flexibility to adapt quickly, significant cost savings, shifting spending from upfront capital investment to ongoing operational costs, much better collaboration for distributed teams, and hugely improved disaster recovery because your data is typically backed up and replicated off-site in the provider's data centers. Now, it's not perfect, of course. There are downsides. Cloud services can experience downtime. There's always some inherent risk putting your data and processes in someone else's hands. Businesses might have less control over the underlying infrastructure. And sometimes, switching between cloud providers later can be difficult. That's called vendor lock-in.
All right, getting stuck.
Exactly. Now, how do businesses actually use the cloud? NIST defines 4 main deployment models. A private cloud is just for one organization, maybe run on their own premises for maximum control and security. A community cloud is shared by several organizations with similar needs, like maybe a group of hospitals sharing compliant infrastructure. A public cloud is open to the general public. Think services like Google Drive, AWS, Microsoft Azure, anyone can sign up. And a hybrid cloud mixes 2 or more of these, maybe keeping sensitive data private, but using public cloud resources for web hosting. That's very common. And the big players. You know them, Amazon Web Services, AWS, Google Cloud, Microsoft Azure, Salesforce.
Okay, so beyond these general models, public, private, hybrid, there are specific ways these services are delivered. We often hear these as-a-service acronyms, ZES.
Exactly. These are different layers of service built on the cloud infrastructure, often using web services software tech that lets different systems exchange info using standard protocols. The most common models you'll encounter are SaaS, software as a service. Here, the vendor hosts the software and you access it through your web browser. No downloads needed. Microsoft 365 is a classic example. Or think of a small online jewelry business using cloud-based accounting software. It's ready to go, easy to use.
Simple and accessible.
Right. Then there's Pay-as, platform as a service. Here, the provider gives you the hardware and software tools you need to develop, run, and manage applications all over the internet. Developers can focus on coding without worrying about managing servers, operating systems, or databases. Think mobile app development kits or point-and-click tools for building web apps, and then IaaS, infrastructure as a service. This provides the basic building blocks computing infrastructure like virtual servers, storage, networking on demand. Organizations use IaaS to avoid buying and managing their own physical servers. They basically rent virtual infrastructure. For, say, a medium-sized web development company with 150 people, Pay-as or IaaS could be ideal. They can scale development environments or host client websites without massive upfront hardware costs. And one more to mention is serverless computing. This is getting really popular. The cloud provider manages all the back-end infrastructure, provisioning, scaling, maintenance automatically. Developers just write and upload their code and it runs when needed. You pay per execution. It lets teams focus purely on the application logic, not the servers. It's a big shift.
Wow, that sounds efficient.
It can be, yeah. But Across all these models, cloud services security is paramount. It involves policies, controls, technology. Before signing any service level agreement, SLA, you absolutely need to ask critical questions. What are their disaster recovery plans? Are they compliant with relevant standards? Do they undergo external audits? How do they separate your data? What encryption do they use?
Due diligence is key.
Absolutely. And related to security, especially for remote work, virtual private networks, VPNs, are crucial. They create a secure, encrypted tunnel over the public internet, letting remote employees safely access the company's internal network as if they were physically there.
That's a fantastic breakdown of the cloud. Now let's pivot slightly to some really cutting-edge stuff that's fundamentally changing ideas about trust and transparency in business. Blockchain and cryptocurrency. Feels like we're stepping into the future here.
It definitely feels that way sometimes. So, blockchain. At its core, it's a distributed, immutable digital ledger. It stores transaction data in linked blocks, forming a chain. Each block contains a unique identifying code called a hash, a batch of time-stamped transactions, and crucially, the hash of the previous block in the chain. This linking is what makes it so secure. Changing any information in an old block would change its hash, which would break the link to the next block, making tampering immediately obvious. It's incredibly difficult to alter past records, and the business applications are really starting to emerge. For business contracts, we're seeing smart contracts, self-executing contracts, where the terms are written directly into code on the blockchain. Secure, automated, less room for dispute. For monetary transactions, its encryption and decentralization make it suitable for secure peer-to-peer payments, potentially cutting out traditional banks.
Reducing intermediaries.
Exactly. It can make audits much more efficient and accurate by providing that tamper-proof transaction history. In supply chain management, it offers transparent, cost-effective tracking. Shippers, retailers, even customers can verify an item's location and authenticity right back to its origin. Great for fighting counterfeits. And for quality assurance, you can trace issues or defects back to the source much more easily, helping investigate and limit damage. The basic process. A transaction happens, it gets verified by a network of computers stored in a block with details and digital signatures. Then a unique hash is added, linking it securely to the chain.
Okay, and that secure ledger technology leads us straight into the world of digital currencies. Cryptocurrency. How does these fit in, and why should business students be paying attention?
Right. Cryptocurrency refers to digital or virtual currencies that exist only electronically. They typically use cryptography for security and operate without a central authority, like a bank. Transactions are recorded on a blockchain, that distributed public ledger we just talked about. New units of cryptocurrency are often created through a process called mining. This involves users running powerful computer hardware and software to solve complex math problems, which validates transactions and adds them to the blockchain. Miners are rewarded with new cryptocurrency for their efforts. Now, creating a new cryptocurrency is complex, choosing consensus mechanisms, blockchain platforms like Ethereum or others, designing nodes, architecture, APIs, interfaces, handling legal compliance with bodies like the IRS and SEC. But for businesses, the key thing is that cryptocurrencies represent a new asset class and potentially a new way to handle payments. You have well-known ones like Bitcoin, BTC, the original, created in 2008, still the most widely traded and accepted by businesses like Starbucks, Whole Foods, Nordstrom. Then Ethereum, ETH from 2015, the second biggest, and it's also a platform for building decentralized apps. You'll also see things like Bitcoin Cash, BCH, which was a fork from Bitcoin, meaning the original code split, creating a new version with different technical enhancements. Businesses need to think about, do we accept crypto? How do we manage these digital assets? What are the tax implications? It's an evolving space.
Absolutely. Okay, one final piece to tie all this connectivity together. Businesses, especially with remote teams and complex projects, rely heavily on tools that help people work together effectively. Collaboration software.
Oh, collaboration software is completely indispensable now. It offers huge benefits. First, just plain better communication, real-time content sharing, instant messaging, updates across the whole organization, breaking down silos. Second, powerful project management capabilities. Project leads can plan tasks, set deadlines, assign work, track progress visually, share files, all within one system. Keeps everyone aligned.
Essential for keeping projects on track.
Totally. Third, it drives improved engagement. It helps remote and in-office employees interact easily, share ideas, feel connected to the team and the company's goals. And finally, it creates a much more streamlined workflow. Scheduling meetings, sharing status updates, managing documents becomes much easier and faster. Less time wasted searching for info. And there are many popular tools out there. Smartsheet is really strong on project management collaboration, uses familiar spreadsheet-like interfaces, but adds web forms, alerts, reporting, discussions. Slack has become almost synonymous with Team Chat. It acts as a collaboration hub, aiming to replace internal email with organized channels. Plus, it integrates with thousands of other apps. Trello uses a very visual approach with boards, lists, and cards. Great for seeing who's doing what and the status of different tasks at a glance. Very intuitive and scales well to mobile. Think back to that web development company example, 150 employees. They would absolutely rely on tools like these every single day to manage complex projects, coordinate between developers, designers, project managers, and clients. These aren't just nice-to-haves anymore. They are fundamental productivity tools.
That was genuinely comprehensive. We've covered so much ground, from the basic building blocks of networks right through to the cloud, blockchain, crypto, and these essential collaboration tools. Thank you so much for joining us on this deep dive. As you, our listeners, future business leaders, and professionals move forward, understanding these core MIS concepts isn't just helpful, it's absolutely vital, it's empowering. So here's something to think about, reflecting on everything we've discussed today. What single technological shift, maybe it's the continued rollout of 5G and its impact on IoT, maybe it's blockchain becoming more mainstream, perhaps the next phase of AI integration and cloud services. What shift do you think will have the most disruptive impact on your specific field of business, or the one you aspire to be in over the next 5 years? And maybe more importantly, how will you as a business professional prepare for that disruption?
That's a great question. Your insights and how you're thinking about applying this knowledge are incredibly valuable. Please do share your thoughts and any questions you have in the comments section below. We really do read them.
Yes, please do. And don't forget to like, subscribe, follow, and share the Deep Dive. It helps us keep bringing you this content and helps others find it too. We look forward to having you join us on our next deep dive right here on Managing the Future, the MIS podcast.